In this video, we're going to review projectile motion. First, I want to just distinguish the difference between free fall motion and projectile motion. So when we're talking about both of these, we are talking about an object that's only under the influence of gravity. For free fall, we're looking at a one-dimensional motion, so just moving up and down. And for projectile motion, we're looking at a two-dimensional motion, so it's not only moving up and down, but also left and right. Now, I want to start with a horizontally launched projectile. And the first thing to note is that on a horizontally launched projectile, the time for it to fall to the ground is the same that if you were to drop it. So if you just drop this, or if you shot it this way and it went this way, they would both hit the ground at the same time. And the reason for that is because they have the same vertical acceleration. They both have the same free fall acceleration. Now, if you were to shoot this ball higher up with the same speed, it's actually going to go further because now it has more time, right? It's got more time to fall, so it's going to fall further. Now let's take a look at objects that are launched at an angle. So this could be like a soccer ball that you kick. So what's interesting about this is that if you were to kick this at 40 degrees, so let's say this is 40 degrees, and you were to kick it at 50 degrees, okay, with the same launch speed, it turns out, going right 50 here, so 50 degrees, okay, so 40 and 50, it turns out they will have the same horizontal distance. We call that the range. So they will have the same range. And it's not just 40 and 50. In fact, you could do it with 20 degrees and 70 degrees. So if you have two angles that adds up to 90 degrees, then they will have the same range. The range is just the horizontal distance. Also, as you increase the angle from 0, to 45 degrees, it's going to go farther and farther. Okay, so it's initially just going to go over here. It's going to go farther and farther and farther up to 45. So as you increase the angle, you're going to increase the range. Okay, but after 45, because at 45, that's your greatest range. So your largest range is going to be at 45 degrees. But as you go from 45 degrees to 90 degrees, okay, now it's going to kind of shoot higher up. It's shooting higher up now and not going as far to the right. And so as you increase the angle, you're going to decrease the range. Okay, so from 45 degrees to 90 degrees. Now, with projectile motion, horizontally, and this is a big idea here, is that horizontally it's moving at constant velocity. So in other words, think about if you kicked the soccer ball and the sun was right overhead and you were to look at the shadow of the soccer ball, right? The shadow is moving and the shadow would be moving at constant velocity. And so we say that the acceleration is 0. Now for the vertical motion, as it's going up, it's going to be slowing down. So it slows down on the way up, okay? And on the way down, it's going to speed up, okay? Now, it's going to change by the same amount. It's just either going to increase in speed or decrease in speed, but the acceleration is constant, and that acceleration is 10 meters per second squared, and that is constant. So let's see if we can illustrate this using a motion map. So a motion map is just a dot diagram. We're going to do these at 1 second intervals. And we're going to start with the velocity. So we'll call this is the velocity motion map. And so we know that horizontally, it has a constant velocity horizontally. So notice the arrows are the same length. But vertically, its velocity is changing. On its way up, it's decreasing velocity. And on its way down, it's increasing velocity. Now, what about acceleration? Let's go ahead and do a motion map for acceleration. Okay, so for acceleration, it's going to always be pointed down, and it's constant acceleration. Okay. Now let's take a look at what the graphs will look like. Okay, so we're going to create 4 graphs. First is a position, burst time graph for horizontal position. The second one will be a vertical position, burst time. Okay, the third one will be a horizontal velocity burst time. And the last one will be a vertical velocity burst time. Okay, so on the horizontal velocity, the horizontal position versus time, the graph will look like this, because horizontally, the soccer ball is going to be moving at a constant velocity. And so think about that shadow example. Okay, so look at the shadow, we'll kick the soccer ball, okay, and then we'll look at the shadows moving across the field at constant velocity. The vertical position is going to change like this. It's going to look like this. So this could be a soccer ball. It could also be a basketball. So you throw a basketball up. So it's going to go up, and then it's going to come back down. This is time, okay? And then for the horizontal velocity, it's going to look like this, because we know it's constant velocity, right? And then for the vertical velocity, it's going to look like this, okay? And why does it look like this? So this is on its way up. It's slowing down at the peak. So this right here is the peak height, highest maximum height. And then now it's going to be speeding up while the ball is coming back down.